Alright, we're going to start a lecture on binary ionic compounds. Let's break it down first. Binary means two, so we're going to deal with two elements. All of our compounds today are going to have two elements. Ionic compounds are where you have a metal plus a non-metal. And those always produce what's called a salt. Or you can also have a metal plus an oxygen, and that will create a metal oxide. Most of the time we're going to talk about salts. Okay. Now the thing with ionics, how to pick out an ionic name is all ionics end in an IDE. So calcium chloride, sodium bromide, lithium, selenide, those all have IND endings, so I know that they are ionic compounds. Okay. So let's read through here real fast. Just again, ionic compounds are between a metal and non-metal. An ionic compound, the metal will always be the cation, and the non-metal will always be the anion. Okay, so we've already learned where the metals are, where the non-metals are, which ones are cations, what are the charges of the metals, and what are the charges of the anions. Okay, the one thing that you got to do first, though, is when you write this, is you always write the metal first or the cation first. So you always write the positive first, and then the anion is second. And again, remember the anion is going to have a IDE ending. We will change the name and put an IDE ending. Okay. And again, our goal here is to balance the charges. You have to have a positive charge and the negative charge to balance. You can't change the oxidation state. You can't change the number, the positive or the negative. Okay, so what you do is you add different number of atoms to make it neutralize out. All right. Let's and again, the cation is always written first. The cation is always written first. Okay, so let's look at these rules here. So we want to write a compound, a binary ionic compound between barium and sulfur. How do I know it's binary? We're talking about two atoms. I don't know. It's an ionic, it's a metal, and a non-metal. So you just basically say, okay, look at your periodic table, go find barium. The symbol is Ba, and it has an oxidation state of +2. That we were going to write that first because the cation is written first. The anion is written second. So write the anion to the right of the cation, and it's got a -2 charge. Okay. So what we have is this. And then all you're going to do is what's called crisscross. Circle the number, only the number, and you crisscross it, and you put it down to the lower right-hand side of the other element. Take the sulfur 2, -2, take the 2, and crisscross it to the barium. Now we have barium, Ba2S2. 2 bariums, 2 sulfurs. Okay. The last thing you have to do is see if you can reduce. Can I reduce the 2 and the 2? I can to where it's Bas. Right. Remember that the oxidation number or the charge is the superscript. This is the higher one. Upon crossing the oxidation, you must write just the number as the subscript. That's the lower symbol. Okay, and the subscript tells you the number of atoms. So here I'm going to have 2 bariums and 2 sulfurs, but I can reduce that to 1 barium and 1 sulfur. Let's try the next one. So we have aluminum and oxygen. First step, find the symbol for aluminum, and it's got a +3 charge. Second step, to the right of that, write the anion, the -1, oxygen, and it's got a -2. Third step, all you're going to do is crisscross the number only, please, just the number. You will never have pluses or minuses down here in the subscripts. Be 3. So last step, erase the oxidation states, and make sure you put the correct number. You have to crisscross it. A lot of people just drop down the 3 straight down to the aluminum, but you have to crisscross. So it's 2 aluminums and 3 oxygens. And then the last step, we check. Can we reduce to 2 and 3? No, we can't. All right. Now this says we have 2 aluminums and 3 oxygen, and it should make sense. For the aluminum, there's a +3 charge. If I have 2 of them, that's a total of a +6. For the oxygen, it has a -2 charge, and since I have 3 of those, that's for a total of a -6. These things bond together so that there is a neutral 0 charge. So this whole aluminum oxide is a a neutrally charged formula. For all formulas, compounds are neutral because of this adding different numbers of atoms to neutralize out the charges. Okay, so let's look at a couple of these. Potassium, you just look at your periodic table. It's got a plus 1 charge. Fluorine's got a -1. So this is just going to be K1F1. We don't have to write the ones. It's just a K and an F. And there you go, potassium fluoride. Bromine and magnesium. Bromine is actually a -1 charge, and magnesium is a +2. You always write the positive first. Okay. Now again, take your time, do multiple steps for these. After a while, you're going to get good enough to where you can just do it in one step. All right. Crisscross the 2 and the 1 only. So we have magnesium, 1 of those, and 2 bromines. Should make sense. If each bromine is a -1 charge, I need 2 of those for a total of a -2. And I only have 1 magnesium, and it has a +2. +2 plus -2 is 0. Strontium. Strontium is Sr. It has a +2 charge. Drop the microphone. Phosphorus is a -3. Crisscross your charges. Don't drop down. Crisscross. Sr3P2. Check for reduction. I can't reduce 3 and 2. Okay. Cesium. And again, you need your periodic table. Cesium is a +1 charge. Sulfur is a -2 charge. Crisscross. So I'm going to need 2 cesiums for every 1 sulfur. Selenium. Selenium and calcium. Calcium is the +2. Selenium is a -2. And here, the +2 -2, we technically crisscross, but at a 1-to-1 ratio, we can reduce that. So it's CaSe. And then the last one is rubidium. Rubidium is a +1. Nitrogen is a -3. Crisscross. So we got rubidium, 3, and nitrogen. You don't have to write the 1. Okay, so it's going to take 1 nitrogen to neutralize out the 3 rubidiums. Okay, naming. All ionic compounds end in IND. 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 Jeez. IDE. 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 Okay, so anytime you see something, a compound ending in IDE, you're going to go bing, ionic compound. Okay, now you can read through all this stuff and do this in your periodic table. I find it's kind of a little almost overwhelming to do all that. You're just going to kind of have to practice and get used to adding the IDE ending. So here's a BAS. You're going to say, oh, that's a metal and a nonmetal. A metal and a nonmetal. If you have to look at your periodic table, that's great. Do it. Barium and sulfur, metal, nonmetal. So you're going to say, oh, metal and nonmetal, that's an ionic compound. So you're going to write the cation first, barium. Just straight off the periodic table, you can't mess it up unless you don't look at your periodic table. And then the next one, you're going to look sulfur. Okay, sulfur, and then it's actually going to become sulfide. Sulfide. You're going to drop the UR, okay, and add the IDE ending. All right, so let's try one more, and then that will be the rest of the notes section. You can try the homework section, and then I will actually post the answers up also for on the next lecture. Aluminum. So I'm going to go, oh, well, that's aluminum. Straight from the periodic table, and then I'm going to go, that's aluminum and oxygen. And you're going to say, hey, this is a metal, nonmetal. This has to end in IDE. Aluminum. And this is going to be oxide. Oxide. Okay, that's going to conclude the notes section on how to write the formulas and name them. And then I will do, you can look on the next set of notes to actually work through the homework here.